Hi, my name is Michael Benben and I'm in Challenge 2016 in Calculus 2000, and today I'm going to be doing my third interactive video assignment where we have to do one of two problems, and my student number ends in an odd number, so I'll be doing number 24 from chapter 8.8 in the Calculus textbook for Calculus 2000. So this problem involves improper integrals. So we're given the integral from negative infinity to infinity of 2x e to the power of negative x squared dx. So in order to be able to integrate this, we had to make two different integrals so we can use improper integrals. So here I split the two up. They're both the same function. However, the integrals are being taken from negative infinity to 0 and 0 to infinity. So now we're able to start using the process of improper integrals to solve this problem. Okay, now that we have split up the two integrals, we have the negative infinity to 0 interval here and 0 to infinity on the other side. So we can start using improper integrals to do this. So we are going to find the limit from b to negative infinity for this side and the limit from b to infinity on this side. Now both are practically the same integrals other than the intervals that we're going to be plugging in. So for both of them we can say that we can do u substitution and say that u is equal to x squared, making du equal to 2x dx and then dx equal to du over 2x, so we can plug it in. Now when we plug it in, we see that the 2's cancel out on both sides and the x's cancel out on both sides. So we end up with these integrals down here, where it's e to the negative u inside of the integrals from 0 to b, from negative b to 0 and 0 to b. And now we can integrate and start finding the answer. Okay, now when we integrate from these integrals, we end up having the limit from b, that when b approaches to negative infinity, of negative e to the negative u from b to 0, plus the limit from b to infinity of negative e to negative u from 0 to b. So now we can plug back in for our u, which gives us the same thing, but obviously with the u plugged in, which is x squared. After that, we can plug in our intervals from b to 0 and 0 to b, and we have within this limit negative e to the 0 plus e to negative b squared, and within this limit we have negative e to negative b squared plus e to 0. Now both of these e's up to the power of 0 are going to be 1, so we're going to have negative 1 here and 1 on this side, and then the other two are going to remain the same, but so that it's easier to visualize, we are going to look at the negative exponent and put that value in the denominator of a fraction. So then we get the limit as b approaches negative infinity of negative 1 plus 1 over e to the power of b squared, plus the limit from b to infinity of negative 1 over e to the power of b squared plus 1. And then from here we can evaluate the limits and see what the answer is for this problem. Now as we continue to evaluate this integral, we find that when we do the limit, the negative 1 remains the same, and we put negative infinity into b squared, that negative will always become positive. So it's the same as saying 1 over e to the power of infinity. So that means that we have 1 over infinity and plus, and then we have the same situation here. Infinity squared will always make e to the power of infinity infinity. So we have that, and 1 remains the same, and 1 over infinity is always going to be 0. So we end up having negative 1 plus 0 plus 0 plus 1, and when you evaluate that all together, we get an answer of 0 for this improper integral. And that will be it for this video. Thanks for watching.